In this video, I'll show you how to do a hypothesis test for a population mean. So here is my Montreal file, and I've already cleaned my data, so I only have the listings that I'm interested in. In this case, I'm only interested in the Ville Marie neighborhood, so I've already gone and deleted all the rows that have nothing to do with Ville Marie. I also narrowed down my property type, so I'm only looking at apartments, condos, houses, and townhomes, and deleted any listings that were not these four kinds. And for the accommodations, I wanted listings that accommodated 2 or more people. So I again deleted any listing that only accommodated 1 person. And I'm also working with price. So I've highlighted the 4 variables that I'm working with so that I can focus on those pieces of information. So here I'm going to work with my pricing data since I'm doing a hypothesis test of the population mean. A mean is an average. So in order to take an average of something, it has to be a number. So I'm going to focus on price. I'm going to click on data and then data analysis. And here's my descriptive statistics I want to run. So I'll hit OK. And I'll make sure that my input range has my column of price. So I clicked on column P. I checked my labels because, yep, I've got price as the label at the top. It's going to go to a new worksheet, and I want to make sure to check summary statistics so that it runs all my analyses for me. So when I hit OK, it'll bring my data over to a new tab. Let's go ahead and zoom in. And I'm going to change this into dollars because I know we're talking about price. Actually, I could change all that into price. Okay. So here is my sample mean. So that's useful for me for my hypothesis test. Now, I need to identify a hypothesized population mean. And I don't want to randomly pick a number, although I could have. I'm going to instead use the median as my hypothesized population mean. So this will be my mu. And then here's my sample standard deviation. And I think the only other variable I need is our count because this is our sample size, my n. So these are the 4 pieces of information that I'll need to run my hypothesis test. So I've provided a worksheet that will help you do this. So our hypothesis test for the population mean for my Montreal example is that I think my population mean is going to be less than or equal to $87, which I chose 87 because that was my median. And our alternative that I'm really interested in is that our mean is greater than $87. And again, the reason for this is that if our average listings is higher than $87, then I know this is a upscale neighborhood where I would want to open up my bike tour business. So for the alpha, the decision maker gets to choose this, and so the commonly used one, which I will like to use, is 0.05. Our sample size in my data, I had 1,503 listings in Ville Marie. The sample standard deviation that I got for my descriptive statistics was 259.84, and the sample mean was $109.32. With my alternative hypothesis, it's a greater than symbol, so I know I'm going to do a one-tailed upper tail test. And for my degrees of freedom, I'm going to take 1503 minus 1, and that gives me degrees of freedom of 1502. So I'll know then for my decision rule that we will reject the null if the calculated value of the test statistic is greater than the critical value. Now to find the critical value, I'm going to go to Excel and use the upper tail test here and type in t.inv parentheses 1 minus my alpha of 0.05 and my degrees of freedom of 1502. And that will give me a critical value of 1.64 4.46. Now I'll go ahead and calculate the value of my test statistic. So here's our formula. So my sample mean of 109.32 minus my hypothesized mean of $87 over my sample standard deviation of 259.84 divided by the square root of my n of 1503. So when I subtract 109.32 by $87, that'll be my sampling error of 22.32. And when I calculate my standard error by taking the sample standard deviation, dividing it by the square root of my sample size, I get 670. And so when I divide these two numbers up, that gives me my test statistic of 3.33. So now to do the critical value method, I'm going to compare my part B versus my part A. So because our test statistic of 3.33 is greater than my critical value of 1.646, we will reject the null. So by rejecting the null, that means my alternative hypothesis holds true. That means that the average price of listings in Villa Marie is greater than $87. And so it would be a good idea to put my bike business here in this neighborhood.